Okay guys, here we go with section P2. Time to put your big kid pants on because this one's going to be a lot harder than the last one. The first thing we're going to talk about is absolute value. And you're like, oh, that's easy. I know what that is. I've done that before. Okay, that's great, except that the definition of absolute value is the distance that a number is away from 0. So if we think about the absolute value of -5, that answer would be 5, because -5 is 5 units away from 0. The problem is it's not always just the negative of the number. So, for instance, if you have, let's see. Well, let's just do some examples. It's probably easier. If you think about the absolute value of -4, you know that that's asking you how far away from 0 is -4 on a number line, right? If you have a number line, -4 is here, 0 is here, it's 4 units away. Distance always has to be positive. So the answer would just be 4. But then you have a question like this, the absolute value of pi minus 6. Well, you have to think about that. Pi minus 6, if this is essentially rounded to 3.14, then when you subtract 6, you have like 2.8 something, right? So if 0 is here, and it's negative, because 3 minus 6 would be a negative, it'd be negative 2.858, or something like that. Well, then the distance is essentially positive 2.858. But how do we describe that algebraically? Because we want it to be exact. We don't want an approximation. 2.858 is an approximation. I want to know, using this stuff, tell me exactly how far away from 0 pi minus 6 is. And the way you do that is you use this rule, which is a little bit tricky. But the definition of absolute value says that the absolute value of A equals A if A is positive, and negative A if A is negative. So, in this case, look back at the absolute value of -4. -4 is negative, so the answer is -4. Well, -4 still equals -4. Wait a minute. No, -4 equals 4. Wow. I'm making this right after your class, and you could tell I was not really at the top of my game today. So, give me a little break. -4 is positive 4. So if A is negative, then whatever's inside A, you make negative to find the absolute value. So in this case, it would be negative pi minus 6, which when you distribute the negative, you end up with negative pi plus 6, which is equal to 6 minus pi. Now, remember, when we did it in our heads, we said pi was approximately 3.14. When you subtract 6, you get approximately 2.858, and that's the distance that pi minus 6 is away from 0. Well, if you do 6 minus pi, that gives you 2.858. All you really have to remember is how far is it away from 0. That's what absolute value is. Okay? The properties of absolute value are as follows. When you have the absolute value of a product, it's equal to the absolute value of the members, the factors. And the absolute value of a quotient is equal to the absolute value of the numerator and the denominator. Those are just fun little facts. Okay, now let's talk about distance. As we said before, distance can never be negative. So when you talk about A and B on a number line, the distance between them is the absolute value of a minus b. So for instance, if I say here's a number line, here's 6, here's negative 4. What's the distance? Well, if I started here and went this way, I subtracted 10, but you can't say the distance is negative 10. Even though you went to the left, the distance is still 10 units, because distance can never be negative. Think about driving. Even if you drive south, you're still driving a positive number of units. So distance always has to be positive. And in this case, it would be 10 units. So it's also the absolute value of b minus a. Doesn't change. If I do 6 minus negative 4, I get 10. If I do negative 4 minus 6, I get negative 10, but it's the absolute value. Distance is positive, so you still get positive 10. Okay, let's talk about the distance formula. When you're given two coordinates, let's say 2, negative 3, and let's say this is negative, negative 5, 4. The distance between them is basically the Pythagorean theorem, which you should have learned in geometry, hopefully. Think about the points 2, negative 3, it's down here, and negative 5, 4, which is up here. I want to know the length of that line segment. I can't very well count because it's a diagonal line, but I could draw a right triangle and use the Pythagorean theorem to determine the length of the hypotenuse. Remember, the Pythagorean theorem said this side squared plus this side squared equals this side squared. Well, how can we describe this side right here? It's the change in the x values, right? It's x minus x. That's the distance we go along the x-axis to draw this side. So this would say that it's the distance in x squared plus, what about this? This is the change in the y. So plus y squared equals our hypotenuse, h squared. That's the Pythagorean theorem. But we have to know the difference of the x's and the difference of the y's. So we have to do x minus x squared, y minus y squared, and then take the square root to find the length of this segment. So the distance formula looks like this. Now, I hate these little 1s and 2s because I think they confuse you. If you just remember x minus x squared, y minus y squared, you'll be fine. So for this particular problem, the distance is the square root of 2 minus negative 5 squared plus negative 3 minus 4 squared, which is 2 minus negative 5 becomes plus, so that's 7 squared is 49, and negative 3 minus 4 is negative 7 squared is 49. So your distance is the square root of 98, which is approximately, I don't know, 9.8 or something like that. But that's how you do the distance formula, and this is the distance formula. You also may need to find the midpoint formula. So we're going to talk about if we have two coordinates. I think the easiest way to think of the midpoint formula is simply the average. 2, 6 and negative 4, negative 8. Think about those 2 points on a Cartesian coordinate plane, or a graph, in other words. Negative 4, negative 8 is way down here. I want to know halfway between those 2 points. Okay, well, halfway is the average. Average is halfway between two numbers. So the midpoint formula is simply the average of the coordinates. Now, some people write it out and say x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. This is a 1 plus 2. If you want to memorize that formula, more power to you. I've come to realize that it's easier to just memorize the average. Average 2 and negative 4. Oh, average. Add up, divide by 2. So that would be negative 1. Because 2 plus negative 4 is negative 2, divided by 2 is negative 1. 6 plus negative 8 is negative 2, divided by 2 is negative 1. So the midpoint, this is midpoint, of this line segment is negative 1, negative 1, because I averaged the coordinates. What else do we want to talk about? Circles. Circles. I should change colors. This color is kind of annoying. Let's go with purple. Circles. Why did that not work? You can't even blame it on the Promethean board because it wasn't. It's just my little ThinkPad. Okay, so the formula for the equation of a circle. Standard form of a circle is x minus h squared plus y minus k squared equals r squared. And hk is the center, and r is the radius. Now, I am fully aware of how dumb it is that they use two different letters, and there's some mathematical derivation that could take hours for me to prove to you why they use the letters h and k. Basically, h represents the x value of the center, and k represents the y value of the center. That's all it is. So for instance, if I asked you to write the equation of the circle whose center was at negative 2, 3, and whose radius is 5, the equation says x minus h squared plus y minus k squared equals r squared. So x minus h would be x plus 2, because it's minus a negative 2. And then y minus 3 equals 25, because that's 5 squared. So if I gave you this equation, actually I'm going to do that on the next page, so hold on. So again, we plugged in the x value of the center for h, the y value of the center for k, and the r gets squared. But if I gave you this equation and said, tell me the center and the radius, crying out loud. That's a circle in standard form. The center is the opposite of this and the opposite of this. So the center is negative 4, 5, and the radius is the square root of this number, because remember in the formula it's r squared, so the radius would be 3. That's how you would do that one. What else do we have to know? We have to evaluate. I'm going to pause for a second. Okay, hopefully that was all review. I'm going to show you one more thing that you're not going to like very much because it's kind of hard, but hopefully you're going to challenge yourselves and you're really going to enjoy it. So you know that if I told you that the sides of a triangle were 6, 8, and 10, and if I asked you if that triangle was a right triangle, then you would say, I don't know, let me check. Does 6 squared plus 8 squared equal 10 squared? 36 plus 64, does that equal 100? It sure does. That means that a triangle with side lengths of 6, 8, and 10 is a right triangle. That's the converse of the Pythagorean theorem. It's backwards. It says, if it works, then it is a right triangle. So sometimes we might give you some coordinates and ask you to determine if it's a right triangle, like this. Here are 3 coordinates that you would plot on a coordinate plane. -3, 4, 1, 0, and 5, 4. Let's see if I have a graph anywhere. Let's see, tools. Math tools. I think I see one. Why is that not working? Maybe I should have figured this out before I tried to make it work. Okay, that's not really what I wanted. XY origin. Oh, well. Okay. If I have... Whoa. That's so weird. I don't know what that thing does, but -3, 4 is over here. 1, 0 is right here. 5, 4. 1, 2, 3, 4. 5, 4 is up here. We want to know if this makes a right triangle. The first thing we have to do, I'm going to erase this because it's really ugly. The first thing we have to do is find the lengths of all the sides. I really want that to go away. Oh, right click. That's my little pen, right? Why won't it give me the close option? Okay. So, let's call this A, B, C. I'm going to find the distance of AB first. You should try this. You should pause the video and try it. When I subtract my x's, I get -4, and then I square it and I get 16. When I subtract my y's, I get 4. When I square that, I get 16. So the distance of AB is the square root of 32. Now I would expect you to show a lot more work than this, but I've been doing this for a really long time, and I don't have a lot of room, and you're supposed to be doing it on your own anyway. I'm just showing you the answers. The distance from B to C, well, the change in x is 4, squared is 16. And the distance from B to C, the y value is 4, squared is 16. So the distance from B to C is the square root of 32. Wow, those are equal. That has nothing to do with whether or not it's a right triangle. It just means it's isosceles. It doesn't have to be right. The change in x values from A to C is 8, squared is 64. And the change in y values is 0. So that equals 8. So now we can say, to find out if it's a right triangle, we need a squared plus b squared to equal c squared. Well, we don't know which one is c, but you know the hypotenuse is always the longest, and the square root of 32 is like 6 point something. So these two sides are not the hypotenuse. Obviously, this one is. So if I do square root of 32 squared plus the square root of 32 squared equals 8 squared. Well, you can see that the square root of 32 squared is just 32. When you square a radical, you get what's inside. The square root of 32 squared is 32, and since that equals 64, we do know that this is a right triangle. And we can also find the area of this right triangle because we know that the base and the height are formed by these two sides. So if I do area of a triangle is 1/2 times square root 32 times square root 32, that's the base and the height, 1/2 base times height, I can say the area of this triangle is 1/2 times, well, the radical 32 times radical 32 is 32, and the area is 16. I'm going to have you try another one of those because I think they're pretty hard. So, the question is this. The side length, or the coordinates, are -3, -1, -1, 3, and, oh rats, that's not a triangle. Sorry guys. If only I could make it so it works. But my brain's not really sharp enough for that right now. So, we're going to start over. Sorry. I'll be able to tell if you took notes because you'll have this huge scribble out in the middle of your paper. Rats, I really thought they would all be triangles. Okay, we'll do this one together. -5, 3. 0, -1. 4, 4. Now the directions say find the perimeter and the area. Well, the only way you can find the area is if it's a right triangle. So first we have to make sure it's a right triangle so that we know which side is the hypotenuse and which are the base and the height. So again, I'm going to find A, B, C. Distance of AB is the square root of x minus x is -5, squared is 25. Y minus y is 4, squared is 16. So the distance of AB is the square root of 41. Distance of BC is 16 plus 25, also 41. This does not usually work out this way. And the distance of AC is 81 plus 1. So again, just like the last one, this is the square root of 82. So if I square this, I get 41. If I square this, I get 41. When I add them together, I get 82, and that should equal the square root of 82 squared, which it does. So that means these two are so the perimeter would be the square root of 41 plus the square root of 41 plus the square root of 82, which would simply, perimeter equals 2 square roots of 41 plus the square root of 82. That's your answer. You would leave it just like that. The area would be 1/2 of that times that, which is 41 divided by 2, which is simply 20.5. That's pretty much the hardest thing in this section, aside from scatter plots, which we're going to do in class. So you absolutely need to bring your graphing calculator so I can show you how to do those on the calculator. All right, have a great day.